All right, part 2. When we look at this, I told you we would be looking at 5 key points. And those key points are anywhere that the sine value is 1 or 0 or negative 1, or where the cosine value is 1 or 0 or negative 1. And on the sine curve, here's my 1, here's my negative 1, and here's the 0. So the first point was 0. Then we end at 360. Sorry, there's the bell. We end at 360, so that's the beginning and the end of one period. I'm going to have to finish my graph starting at 0 and ending at 360. And these right here are the quarter periods. Now, why is it called a quarter period? Just like in a dollar, there's 4 quarters. In every period, there are 4 quarters. And my quarter period is 1/4 of the full cycle. So if I plot my points at 0, 0, my next point goes to the first quarter and it goes up. My next point would go to the second quarter and it goes back to the middle. Remember I said midline, maximum, midline. The next one is going to go to the next quarter and go down to the minimum. And the next one would go back to the midline. And there is my sine function shape. And my cosine function, same concept. Here's 1, here's negative 1, 0 to 360. Here's my first point, and then 1, 2, 3, 4. Only remember, cosine didn't start at the midline. Cosine started up here at the top. So the next point would be middle, bottom, middle, top. And we have the cosine curve. And I like to say this one looks kind of like a snake for sine, and this one looks like a cup for cosine. Well, what if I had a reflection? What if I needed to draw a negative sine curve? Well, we'd still start at our middle value, but instead of going up first, our next quarter would be down, and then back to middle, and then up, and then back to middle. And it would look just like that, only upside down. And for the cup, we would start at the bottom, go to the middle, top, middle, bottom, and we would connect our curve like this, and it looks like the cup is upside down, like it is negatively pouring whatever was in the cup out. So when I look at this shape, do you see sine or cosine in that shape? Let's take a look at it. First of all, here's my midline. This is the sinusoidal axis. Let me mark that. I'm going to call it the midline, but I'm also going to, in parentheses, put sinusoidal axis, because we need to call it by its right name. Sinusoidal axis. Okay, and that's this line right here. It's through the middle of my shape. This line up here is my maximum, and this one's drawn in the wrong place, so make sure you fix it. It actually goes underneath the bottom, and that's the minimum. So if I was going to list the range of this graph, whatever this minimum value is would be my lowest, and whatever this maximum value is would be my highest. And that would be my range from minimum to maximum. And this midline, this sinusoidal axis, runs right through the middle. This distance from the midline to the top, remember I told you that was the height? Well, it has its own name now too, and that name is amplitude. The amplitude is the height or distance from the midline to the maximum. And once again, notice that that matches right here. So the amplitude is the same from whether it's up or down. Now, because it's distance, amplitude is always positive. Our amplitude value always needs to be positive because it's always from the midline up distance or from the midline down distance, but it's a distance. And we could find a period either going from here to here. This is one period of cosine. Okay, that's one period of cosine. See the cup? But what if I wanted my graph to go from here to here? That distance, if I were to measure it, is still one period. It's still the same distance. This distance matches this distance. Look, my fingers don't have to go any further apart. They just both moved over. So what's the difference? What you need to understand is every sinusoidal can either be given an equation that's cosine if we start at the top of a cup, or sine if we start at the midline. So I could have named it cosine starting up here. I could have named it sine starting at there. See between my fingers the snake shape? What if I'd have started down here? What would that one be? That one would be negative cosine because it starts all the way at the bottom, just like this pink one. And what if I had started right here at the midline, but dropping first? That would have been a negative sine equation. So when I ask an equation, if I say give me an equation for the graph, I will never say give me the equation. I will say give me an equation because there are multiple equations you could write. You could write a positive cosine equation right here, like a cup. You could write a negative cosine equation right here, like a cup that's spilling out. But notice something else. Every single one of those graphs start at a key point. Whether I call it sine, that starts at this key point. Cosine starts at this key point. Negative sine starts at that key point. Negative cosine starts at that key point. So the distance from the y-axis, to whatever starting point you name is called your phase shift. So if my phase shift was a sine equation, it would be from the y-axis to that point. There's a different phase shift up here for cosine. This is the phase shift if I had chosen to start my graph right there. So the phase shift just means where are you starting your graph. If you're starting the sine equation,
good afternoon.
Sorry about that, that was an announcement. If you're starting a sine equation, my phase shift would be here. If I was starting with a cosine equation, my phase shift would be here. So now when I use the words sinusoidal axis, that's your midline, amplitude, that's how tall it is, always positive. The period means how wide it is, but from the beginning of the cycle to the end of the cycle. And the phase shift is where your cycle started. And that's different depending on which key point you choose. Now, once we have the basics down, we're going to start transforming our equations. That means we're going to start moving them around. We're going to make them taller, we're going to move them up and down, we're going to make them wider, we're going to move them left or right. We're going to be doing transformations. Now, you've seen all these transformations before. You've seen vertical transformations, that's up and down. You've seen horizontal translations, that's side to side. You've seen stretches, vertical stretches or compressions. That's going to be the value that makes it taller or narrower. The one you haven't seen much of is a horizontal stretch or compression, and that is going to affect the period of the graph. Let's fill in these notes together, and then we'll come back and do an analysis of what each of the different numbers in an equation represent. Okay, this is the graph of 4 sine of x. How do I know? Well, first of all, it's a sine curve. It looks like a snake. And instead of going from -1 to 1, this is a dilation. Look where that number 4 is. It's in front of the graph, and it goes from 4 to -4 instead of 1 to -1 because we made it 4 times taller. This graph has 4 quarter cycles, 4 quarter periods, right? There's one period, 360 degrees. And then a quarter cycle, this would be 90 degrees, 180, and 270. Can you see, though, my 5 key points? Well, what's the location of that point? That point is located at 90, 4. So I could actually name each of the key points simply by knowing my maximum, my minimum, my midline, and my period length. Well, that's the reason every question says, where's the sinusoidal axis? Well, it's at 0. It didn't move up or down. And what's the amplitude? The amplitude is 4. On this next problem, the sinusoidal axis is going to be at 3 because it did move up or down. See the plus? The amplitude, however, is back at 1 again. That first number in front right there is 1. So this is going to be a height of 1 and a shift up of 3. Let me show you.